Hello guys, Cristiano here. I am a C programmer, learning all those things that I can. Hit the subscribe button, let a comment, that'll help so much the channel. All my videos will be in a fast mode with explanation. I'll reduce the time to be more precise. And we will face a lot of mistakes and debugs. Everything is calculated, or not. So don't be afraid. The link for all the source codes will be in the description. If you wanna follow, just get your copy. In this video, we will introduce MQTT to our toolbox. This will make it easier for us to use MQTT in our projects. We start by creating MQTT include and its source file. I also create a test folder. Next, I create a file to add the compilation rules, adjust the compilation variable, rename the include, and add the MQTT folder containing the headers to site includes. I link with the PAHO library and adjust the installation of site MQTT. In the include directory, I create a site MQTT folder, then I create the message header, make the necessary includes, and proceed to create the QoS header. Here we define the QoS types that MQTT uses, fire and forget, at least one, and once and only once. If QoS defined, we return to the message header to create the message structure, which contains a topic, a payload, and payload size, and a QoS. Next, I create another header named persistence. In it, we define the types of persistence, which are default, none, user, and error. These new headers need to be added to installation because they are public headers. I proceed with indentation. In the set MQTT header, we include the status, persistence, and message headers. We define a user callback for receiving messages, and another for when the connection is lost, indicating the reason. We create an enumeration to define the type, subscriber or publisher. We start creating MQTT context, which includes the handle, type, and the data. We create an internal structure to group events. Then we create the arguments that include the address and ID, the persistence type, the type, user data, and the events. Now we proceed with the boilerplate by creating the basic functions: init, open, publish, subscribe, and close. I adjusted the signature, noticing I forgot I closed, but I will correct it soon. I copy those functions and move them to the source file. I included the necessary headers and paste the functions. Continuing with the boilerplate code, I fill the functions with the base implementation, which I take from sat.log. I paste into the init and make adjustments for the type and the text. I move on to open, adding args to verification, then to publish, verifying the message, and finally subscribe, verifying the topic. I add more includes, this time including MQTT client, and define the timeout to disconnect, with a value of 10,000. In the open, I use the while false to initialize the MQTT. First I verify the argument, then I create the client, copy the arguments to the context, register the callbacks, and connect the client to the broker. Now implement all these functions. First, we define the prototype for each one. We copy them now to the end, and I adjust each one. In publish, I verify the client's a publisher, and if the message is valid. we create the MQTT message from our message and add a new function to create the message. I add its prototype and skeleton and publish the message using the handle, topic, and converted the message. If successful, I return true, and subscriber, I check if the handle is not null, and if it is a subscriber. Then I subscribe to the top, waiting for 1 milliseconds per loop to avoid consuming processing power. And in close, I perform a disconnect with the timeout disconnect and destroy the client instance. Verify if the handle is not null. Implementing the support functions, start with is args valid. I check if all fields are correctly filled. In the client create, I use the handle, address, ID, and the persistence from args. If it's created successfully, it returns true. In args copy to, I copy all the arguments to the context. And in callback register, I register the internal callbacks that we will create. First receive, then lost connection. In the lost connection implementation, I retrieve the context via cast and call the user callback if it is set. In onReceive, I retrieve the contact with the cast, create the message, and clean it with the main set. I copy the references from the MQTT messages to the set message. If the onReceive callback is implemented, I pass the field message to it, then free the message in the topic. In client connect, I define an options variable and I initialize it. Then connect using these options. We connect, it returns true. In its message valid, I check if the payload and topic are not null and if the size is greater than 0. In message create, I create an MQTT message from our message. I'm not using retain for now. In CMake, I create an option to enable MQTT, add its dependency, and add the test folder to CMake tests. I adjust the test compilation rules. And prepare a Docker Compose to bring up the Mosquito broker, creating a configuration file to initialize the broker and adding the Mosquito folders to git ignore. In the test, I include necessary headers, I create defines for the directory and exit, and set up the reception message used by the consumer. I check if the message is exit, stop the Docker, and I end the application. Otherwise, I display in the message. I declare the functions for consumer and producer threads. Create two variables for these threads and launch the broken container. I start the threads with their functions and wait for them. implement the threads, I start with the producer, create a MQTT instance and a counter variable, initialize the instance with init and parameterize with open. Fill in the argument with the broker address and the port, the ID, and set it as publisher. In a while loop, I increment the counter, check if it is less than 5, and publish a message to the test topic with a message test, edit size, and a QoS at least 1. Waiting 10 milliseconds between sends. When the loop ends, I send the exit and close it to the instance. I copy everything to the consumer, making some adjustments, change the type to subscribe, and add the callback to receive messages, passing that as consumer. Subscribe to the test topic with QoS at least 1, and close the instance. Compiling, I remove configuration and enable site MQTT. The build proceeds fine. Although I noticed some warnings, return to the test, I add the miss include, clean, and recompile without warnings. Running the test, it doesn't terminate, bugs. I ended up interrupting, try running again, and still nothing. I check configuration, suspecting the container isn't launching the broker due to the missing directory change. I recompile and test again, still no luck. I check the publish settings, ensure the topic is correct. And review the consumer configuration. Change the ID consumer, as both applications had the same ID, still nothing. I keep investigating the problem. Testing directly on the binary. Still nothing. It's time to debug. I start by debugging the producer. Checking configuration steps and various points like return values. I notice a false return when published after verify the message. Change it to true. I compile it, test again, and finally works. It is funny how a single word can make such a difference, right? Now we have MQTT in our toolbox, and we can use it easily and simple. That's all for now. I appreciate it if you get here. Don't you forget to hit the subscribe button, leave a comment and share. Knowledge is not enough. Waiting for more. Bye. See you soon.